This video will cover lesson 5, which is solving absolute value equations and inequalities. There's a little typo, there was a 2 in there, I don't know where the 2 came from, so you can cross off the 2. This is lesson 5. Let's talk about, the first question on the notes is, what is the absolute value of a number? Do you know the definition of the absolute value? Take a second, think about absolute value, and write down what you know about absolute value. Okay, hopefully you said something about the distance from 0 on a number line. If you didn't think about the distance from 0 on a number line, you need to write that down. That really is the most precise definition, the most useful definition. Some people think it's always positive. Well, that's kind of true, kind of not. I mean, it just depends on the situation. So yes, whatever's in there, like if this was absolute value of -5, that means positive 5. That's true. But the real meaning is the distance from 0 on a number line. So that is the absolute value. So as you look at these 3, what would the solutions be? So if the absolute value of x is 5, what are my possible answers? Well, one would be x is 5. Hopefully everyone knows that because that's going to work. But there's another one that works too. X equals -5 is also a solution. And so when I graph that on the number line, if I put a 5 on one side and a -5 on the other side, each of those is just going to be a point. It includes 5 and it includes -5, both of those. All right, how about the next one? The absolute value of x is equal to 7. Well, hopefully you're thinking the same thing as we were doing before. That is, x could be 7 or x could be -7. And again, we have 2 singular points here at 7 and -7. What about the absolute value of x is -5? What are the solutions there? No solution, right? There is no number you could plug in there that would give us a negative answer because, like some people say, it's always positive. So that's just not possible. What do you notice about the solutions to an absolute value equation? There are usually 2 solutions. Okay, usually 2 solutions. Sometimes there are no solutions, and sometimes there's one solution. Can you think of when there would be one solution? It's just going to be absolute value of x is equal to 0. If it's 0, it's just 0. So that would be the one solution possibility. There are sort of the no solutions possibilities, but typically there are 2 solutions. The next section is this table. I would like you to pause the video and I want you to see, can you come up with, if this is the inequality, can you come up with the interval and then can you graph that interval? This is something we started to look at the other day with our inequalities, and so I think you have an idea of how to do it. Pause the video and see what you can do on coming up with the intervals and the graphs. Okay, my guess is that you were able to do some of these. You might have gotten kind of stuck on some of them. I'm going to run through some of them real quickly and I'll spend some more time on others. If it is less than 3, that means it goes from -infinity to 3, and so your graph, it has a parenthesis on the 3 and it points to the left. The second one, x is greater than -2, so there's a parenthesis on the 2, points to the right, greater than. The next one, x is less than or equal to 4, so we put a bracket on our 4 and we point it to the left. X is less than or greater than or equal to 5 would be 5 from 5 to infinity. So it goes from 5 to infinity, bracket on the 5 going to the right. All right, these 4 might have been a little bit more difficult. This says -6 is less than x is less than 1. Another way to say that is x is in between -6 and 1. So that's what this is saying. From -6 to 1. There are no equal signs, so we put parentheses. When we put that on the number line, we put a parenthesis parenthesis on each number, and we just put our solid line in between. Similar here. 5 is less than or equal to x is less than or equal to 11. So it goes from 5 to 11, including 5 and 11. It has the equals. So that's a square bracket on the 5 and the 11 and filled in between. The next one, negative 6 to 3. This time one of them is a parenthesis, one of them is a bracket. So one of them is less than, one is less than and equal to. So we're going to have a parenthesis on our negative 6, square bracket on our 3, line in between. And then the last one, once again, one is a bracket, one's a parenthesis, so we have to have an equal to with the 2, not an equal to with the 4, and we put our bracket and our parenthesis and we go in between. So you need to be familiar with how to do interval notation and how to do, you know how to do these already. Hopefully these are familiar to you. These are the ones that are newer. We're working with them this year, but they're newer. And then also how to graph using those parentheses and brackets, which we've practiced a little bit already. Let's take a look at some absolute value equations. One thing we need to remember is we just at the very top talked about there's usually more than one answer. So we might want to remind ourselves of that. Usually 2 solutions. Well, how do we find both solutions? What we do is, remember from up above, some of them, let's go back up there. One came out as a positive 5, the other one came out as a negative 5. One came out as a 7, the other comes out as a negative 7. That's what we're going to do to set up our equations. In the same way, we're going to say, well, one time it's going to be 13, and the other time it's going to be negative 13. And so what I'm going to do is I'm actually going to solve 2 separate problems. One of my problems, all I'm going to do is just drop the absolute values and solve it. So I'm going to subtract 6 from both sides. I get x is 7. The other way to do it, the other thing I need to do is do the same thing, but this time I have to say, well, I'm supposed to have 2 answers. One of them's positive, one of them negative. So I'm going to make this a negative 13. Again, drop the braces and make it a negative 13. This time when I subtract 6, I get a negative 19. So my 2 solutions should be negative 19 and positive 7. In the instructions it says to check your solutions. That's going to be really important because they don't seem to make much sense as it is right now. So let's check them. I'm going to do an oral, I'm just going to check them out loud. Okay, I'm not going to write it down, I'm just going to check it out loud. If I plug in a 7, that's 13. Absolute value is 13 is 13. That works. If I plug in a negative 19, if I plug in a negative 19, I get negative 13. The absolute value of negative 13 is 13. So both of those work. Notice they look like 2 totally different answers. That happens, okay? Let's look at number 2. Same type of thing. We're going to make one positive, one negative, and then we're going to solve it. It's just a little bit more complex. It's just not as straightforward as the other one. So I'm going to set one of them 2y minus 4 equal to 12. I'm going to set the other one 2y minus 4 equal to negative 12. And now when I solve them, I'm just going to go through and solve it algebraically like I normally would. So I'm going to add 4 to both sides, and then I'm going to divide by 2, and I get 8. On this other one, I'm going to add 4 to both sides. That's a negative 12. So negative 12 plus 4 is negative 8. I'm going to divide by 2 on both sides, and I get negative 4. Now, my answers are negative 4 and positive 8. I need to check those because, again, they just don't seem like they're related at all. So let's see. If I plug in an 8, I get 16 minus 4. 16 minus 4 is 12. That works. If I plug in a negative 4, I get negative 8 minus 4. Negative 8 minus 4 is negative 12. Absolute value of negative 12 is 12. So we have come up with the right answers. I have these number lines here. Honestly, we don't really need a number line when we have an equal sign, okay? We will need the number signs for the inequalities, but not so much for the equals. Here we have, I'm going to skip number 3 because it's really just more of the same. Well, actually it's not, is it? Let's take a closer look. Absolute value of this is equal to negative 3. How are we going to do that? Guess what? It's no solution. Why not? Well, because you can't have absolute value can't be equal to a negative number. So that's a no solution. The next one I definitely do want to look at because it's a little bit more complex. And the idea on number 4 is that you have to isolate the absolute value before you solve, or excuse me, before you break it up. In other words, I'm not going to do 10 and negative 10. That's not how it works. I have to get the absolute value by itself and then do the positive and the negative. So I actually need to isolate this. In other words, I need to add 5 to both sides. And then I need to divide by 3. And that's 5. Now that my absolute value is by itself, now I'm ready to break it up, okay? So this is my absolute value. So now I can say 4w minus 1 equals positive, that's a 5, positive 5. And I can try 4w minus 1 is equal to negative 5. Don't use the 10 and the negative 10. You have to isolate it first. Okay, so if I'm going to start over here. So if I do this one, I get 4w equals, I add 1 to the other side. That gives me a negative 4. So that's w equals negative 1. This one, I'm going to add 1 to the other side. I get 4w equals 6. I divide by 4, and I get 6 over 4, which does reduce to 3 over 2. So my two answers are 3 halves, or 1.5, and negative 1. Of course, I want to check those. It's a little bit longer check this time. I might go ahead and write it out since it's such a longer check. If I plug in, I'm going to call it 1.5. Some people are easier with a 1.5. So if I plug in a 1.5, okay, so I have 3 times, that is 6 minus 1 is 5, and then I have minus 5. Well, that's 15 minus 5, which is 10. That works. I'm going to try my negative 1. And again, I'm going to write, since it's a little bit longer, I'm going to go ahead and write it out. 3 times 4 times negative 1 minus 1 minus 5 is equal to 10. Okay, so inside the absolute values, PEMDAS says, you know, the P doesn't just mean parentheses, it's any grouping symbol. And an absolute value is a grouping symbol. And while we're on that, never, ever, ever distribute inside an absolute value. This 3, you cannot distribute that. It does not work that way. Okay, but let's move back to where we were. Negative 4 minus 1, negative 4 minus 1 is negative 5. So I have 3 times the absolute value of negative 5 minus 5 is equal to 10. Okay, absolute value of negative 5 is 5. 3 times 5 is 15. 15 minus 5 is 10. That works. It's important to check your answers on the absolute values. Okay, we have these words when we talk about compound inequalities. And here's the deal. The reason the compound inequalities are with this is compound inequalities and absolute value inequalities are really the same thing. So we'll get to see that. We have these words of disjunction and conjunction. And what does that mean? Okay, well, a disjunction is when you have an or statement, and when you have that, you use the U symbol like we were using with our sets, because you're going to have two separate pieces. When you have a conjunction, then you use the other symbol, which is an upside down U, and that means you just have one. It means you're only graphing in between. Okay. So the disjunction, we graph this, we have a -2, we have a +3, it is less than -2 or greater than +3, and so it looks like this. If we have a conjunction, that can also be written like this. The book that we're using, which is of course last year's book, they write them like this, which there's really no reason to, because it really can be written like this. Let's take a look and see. Because if you have your number line, you have a -2, and you have your +3, greater than -2 goes this way, less than -3 goes this way. That's the exact same thing as this, between -2 and 3. So this is an or, this is an and. And that is related, like I said, to absolute value. So let's go ahead and solve a compound inequality, and then we can go down to absolute values. When you have a compound inequality like this, you basically are looking at it as a 3-part equation instead of just a 2-part equation. And anything you do to one part of that, you have to do to all 3 parts. So just like we do with an equation, if you add on one side, you have to add on the other. Well, in these, if you add one thing, you have to add it to all 3 parts. So we're still isolating that x, and so we look to find what we have to do, but we have to do it to all 3. This comes out to be a +2, 5x, and 20. We're going to divide by 5. When we divide, we have to divide all 3 parts. So I divide all 3 parts. I'm going to come up here because I'm out of space. And so 2/5 is less than x is less than or equal to 4. If you divide by a negative, you have to flip the signs. We didn't do that, but I'm just bringing it up that can happen. All right, so our interval notation, it says write your answer in interval notation, is from 2/5 to 4, parenthesis on the 2/5, bracket on the 4. And let's go ahead and graph that. So our graph is going to look something like this, and 2/5 has the parenthesis, 4 has the bracket. Notice the parenthesis and bracket that you use here are the same as the parenthesis and bracket you use over here. Okay, let's look at the next section. Again, now we're tying it into absolute value and seeing what this has to mean with absolute value. Okay, we had this at the beginning of the lesson. Absolute value of x is equal to 5. That means x can be 5 or -5. We already talked about that. What if the absolute value of x is less than 5? Well, now we've got to have some kind of like graphing and shading going on, right? Well, let's think about this. The absolute value of x being less than 5, remember that the absolute value of x means distance from 0. That's important. This is saying the distance to 0 is less than 5. So the distance to 0 is less than 5. That means it could be 1 or 2 or 3 or 4, all the way up to 4.999999. So and the same way in the negative direction, obviously. So because it is less than, it's going to show up like this. Let's use that same logic for the next one. Distance to 0 is greater than 5. The distance to 0 is greater than 5. It's more than 5 away. It's 5.1 and higher, and negative 5.1 and higher. So if it is a less than, it's in between, it's a smaller value. If it's a greater than, it's greater than, farther away to 0. What about the absolute value of x is equal to negative 5? Not possible. Hopefully I didn't trick you on that one again. That is not possible. Okay, let's take a look. Solve each example, give your answer in interval notation, and graph it on a number line. All right, we talked about this a minute ago, that when you have this, you have to have a positive and a negative. So I'm going to take those absolute values off, and I'm going to rewrite one of them just as it is. The other one, I'm going to make with a negative 13. Well, guess what? If I do a negative 13, I have to switch the sign. It's kind of like when you divide by a negative, you have to switch it. Okay, so I'm going to switch the sign the other way. So I'm going to have one exactly like it without the bars. I'm going to have the other one just almost like it, but I have to flip the sign and I make it negative. Now I can solve. I'm going to subtract my 4. I'm going to divide by 3, and I get x is less than 3. Over here, I'm going to subtract my 4. I'm going to divide by 3, and I get negative 17 over 3. In this class, I would prefer you leave it as an improper fraction. Don't give a decimal, don't give a mixed number, just leave it as an improper fraction. It also asks for it in interval notation, and also asks to graph it on a number line. Let's take a look at the number line, what that would look like. So we have a negative 17 over 3, and we have a positive 3. And I just said a minute ago, don't change that to an improper fraction, but if you think about that, isn't that about negative 5.6 repeating? Okay, so just so you have an idea of where it is. And it says it's less than negative 3, and it's greater than negative 17 thirds. So my interval is negative 17 thirds to 3. Let's do the next one. Let's go ahead and take a look at number 2. So once again, I'm going to keep one of them the same. Just drop the brackets, the absolute value bars. The next one I'm going to do, flip it and make it negative. Because anytime you do that, if you make it negative, you have to flip it. So we're going to add, that's 4x greater than or equal to 28. Divide by 4, we get 7. Over here, we're going to add, this time negative 21 plus 7 is a negative 14. We're going to divide by 4. We get negative 14 over 4. And even though I don't want you to make it an improper fraction, you absolutely do have to reduce it. So we're going to simplify that to negative 7/2. I'm kind of running out of space here, so I'm going to come down here and make my number line. Negative 7 over 2 is kind of like negative 3.5, right? Positive 7 is over here. It says it's less than or equal to this one, and it's greater than or equal to this one. How about our interval? This is going to be one of those intervals that we have that u in between. So we're going to go from negative infinity to negative 7 over 2. Of course, we always do parentheses on infinities, and we'll do a bracket on that one because of that. or we have 7 to positive infinity. So there we go. That all goes with number 2, okay? Since I've kind of encroached on the space for number 4, let's just talk about number 4. Remember that thing about distance from 0? Can the distance from 0 be less than -5? That doesn't really make sense, does it? That the distance from 0 is less than -5. So number 4 is going to be a no solution, okay? So like I said, I kind of encroached on that space. Let's go ahead and write that in there. That is no solution. You can't have a negative distance to 0. That doesn't make any sense. Number 3, we are not going to do a 16 and a -16. Remember, you have to look at the problem. This has a +5 in it. We have to isolate that absolute value before we break it up. So that's going to give me a 2x plus 9 less than 11, because 16 minus 5 is 11. And my other one is going to be 2x plus 9 is greater than, because I have to flip the sign, greater than -11. So 11 and -11, because 16 minus 5 is 11. All right, now that I've done that, now I'm ready to solve it. So I'm going to subtract 9 from both sides. 11 minus 9 is 2. So x is less than or equal to 1. Here, I'm going to subtract 9 from both sides. When I do that, I get a -20. I divide by 2. And so my number line, and make some space for my number line, my number line is going to have a -10 on it and a +1. It is less than 1. It is greater than -10. So this is my graph. And my interval then is going to come from that graph, which is from -10 up to 1. That's my interval. Sometimes I think it's easier to graph it before you do the interval. It's just personal preference. I'm kind of a more visual person, so I do that and then I can come up with this afterwards. Okay, once again, I don't think we have any space here for a summary. It might be worth summarizing because I feel like we've done a lot of things. You may or may not have room for a summary. If you're going to write a summary, I think some things that you would need to write are that absolute value usually has 2 solutions. You might write that the absolute value is distance from a number line, or distance from 0. That's how we figured out some of those problems, was distance from 0. That made more sense than just saying absolute value. You might say that if you have an absolute value inequality, you have to break it up into 2 separate problems. And you might say that before you break it up, you have to isolate the absolute value. So before breaking into 2, isolate the absolute value. Those would be my suggestions for a summary. Here's the deal with summary. It helps you in the moment go back and remember, which is then going to help you down the road go back and remember. In addition, when you're studying, now you have it all right here, and you can just look at that summary and quickly recognize what it is you learned. So that's why we do that. It's just a good note-taking method, and it's just a good brain stimulation method. Okay, that is the end of the lesson on absolute value equations and inequality.